Welcome to today's deep dive. We are exploring a stack of highly specialized product specs from VPI, sourced via HDTVSupply.
Yeah, some really fascinating stuff in here.
It really is. And our mission today is to uncover the hidden, incredibly high-stakes world of professional AV and networking infrastructure. Like, figure out why seemingly simple tools command these massive jaw-dropping price tags.
Right, because the numbers are wild.
Okay, let's unpack this. Picture walking into a massive high-end sports bar. You've got 80 screens, all perfectly synced, crystal clear 4K, zero lag.
It feels like magic, honestly.
Exactly. It feels like magic, but behind the walls, it is an engineering fortress.
Well, and to build that fortress, you can't just buy off-the-shelf gear and, plug it in. The margins for error at that commercial scale are virtually non-existent.
Which brings us to the first item on our list.
Yes, which is why we're looking at things like the VPI Montest HD4K. It's a 4K Ultra HD HDMI video test pattern generator and analyzer,
Yep.
and it retails for $2,100.
$2,100 for a test pattern generator? I mean, is this basically like buying a $2,100 tuning fork for an orchestra instead of just using a piano app on your phone?
What's fascinating here is that that's actually a great way to think about it. You aren't just checking to see if a television turns on, right?
Yeah.
This device generates over 100 specific video patterns.
Wow, 100.
Yeah, over 100. It tests 4K by 2K resolutions at 60 Hertz with full 4.4.4 color sampling over both HDMI and VGA.
Oh, wait, hold on. Let's slow down. Full 4.4.4 color sampling sounds impressive, but what does that actually mean for the viewer?
So most video we watch on streaming services compresses the color data to, save bandwidth.
Yep.
It groups pixels together and guesses the colors for entire blocks. But 4.4.4 means zero color compression, like every single pixel gets its own dedicated color data.
Oh, I get it. So it's the difference between looking at the overall picture of a tapestry versus, like, inspecting every single individual thread to make sure the dye is perfectly matched.
That's a perfect analogy. And it matters because commercial setups rely on a matrix switcher. Think of a matrix switcher as the ultimate digital traffic cop for a massive building.
Right.
It takes dozens of inputs, like 10 different satellite boxes, and routes them to dozens of different screens simultaneously.
Sounds incredibly complicated.
It is. If there is a tiny data error at the source, it cascades through that matrix and ruins the image everywhere. So you need absolute pixel-perfect calibration before you even think about routing the video.
Okay, so we use the expensive tuning fork to get the perfect signal. But sending that flawless signal from the digital traffic cop out to those 80 screens means relying on physical cables.
Mm-hmm. Exactly.
And the specs here reveal something wild about how those cables are actually built.
Yeah.
Here's where it gets really interesting. We're looking at the VPI RJ11 die-E and the RJ45 die-E.
The crimping molds, yeah.
Yeah, these are literally just crimping molds that shape the little plastic clips on the ends of network and phone cables. But the RJ11 die costs $900. And the RJ45 die is $860.
It's a lot of money for a mold.
Right. For $900, you could buy 100 manual hand crimpers from a hardware store.
Yeah.
Why do we need hydraulics for a tiny plastic plug?
Well, if we connect this to the bigger picture, you have to look at what these dies actually fit into. They are interchangeable components for heavy-duty industrial machines like the VPI CM-60W or the CM-90W.
Okay, and how much do those run for?
Those base machines cost between $3,130 and over $3,500.
Wait, so we're spending almost $5,000 total just to attach a plastic clip to a wire.
You're spending $5,000 to automate the process with hydraulic and air compressors. Let's look at the physics of a network cable. Inside that cord are twisted pairs of copper wire.
Right.
They are tightly twisted together to cancel out electromagnetic interference. If a human manually crimps the plastic end and untwists those wires for even a millimeter too long before they hit the metal contacts, the electromagnetic field breaks down. Yeah, it creates electrical crosstalk, where the signals bleed into each other, causing massive data packet loss.
And when a technician is making thousands of cables for a commercial installation, human hands become the ultimate liability. You aren't just paying for a tool, you're paying to eliminate human error entirely.
Yeah, precisely. When you are broadcasting a live event to thousands of patrons, a single dropped packet from a bad crimp means a screen goes black. At a certain scale of technology, reliability is the only feature that actually matters.
So what does this all mean? It means those flawless, magical tech experiences you take for granted require massive, hidden, heavy-duty investments.
They really do. Though, looking at these specs, you do get free shipping in the USA and a 5% discount if you pay by wire transfer.
Hey, there's your silver lining.
Mm.
Flawless tech requires an infrastructure philosophy where even the cheapest components are treated like mission-critical hardware.
Yeah.
Which leaves you with a thought for the day. If preventing a single cable failure for a sports bar requires a $3,500 hydraulic machine, how much of your own everyday digital life is currently hanging by a thread of cheap, manually crimped wires?